Okay, so today we're going to be doing section 7.2. This is going to be question number 9 on the review. So we're going to be using substitution. Now, we all had a hard time in class doing this, but I actually know how to do this problem, so I'll show you guys how to do it. So basically, we need to find something to be our u value, and it's usually easiest to just choose the thing that's under the radical. So we're going to have u equal 4z squared minus 5. Okay, now we're going to go ahead and take the derivative of that, just the regular derivative. So we're going to have du equals, so bring the 2 down, 2 times 4 is 8z, and then that's just nothing. So we're going to have 8z dz. So as you can see right now, we have a z here, check, and then we have a dz here. So we're good, but we don't have an 8. So what you're going to do is divide both sides by 8. So we're going to have 1/8 du equals z dz. So that basically just means we're going to have, when we actually go ahead and solve the problem, we're going to have this weird s thing. We're going to have 1/8 times the square root of u. Now if you're wondering why it's the square root of u, it's because we had u equal this, just square root, and because that's what the function is. So now we're going to have dz. So now we have our formula. Now we can actually simplify this. We're going to go from 1/8, take that 1/8 out, just u. Now what you guys need to know is that the square root just means to the 1/2 power, okay? dz. So now that we got here, we can now take the antiderivative of this. So we're going to add 1 to the top. So if you basically add, so you see that there's 2 on the bottom, so you can add 2 to the top, so that's going to be u to the 3/2 dz, and make sure you put that over 3 over 2, because whatever on top is going to be on the bottom, 1/8. Okay? But now that we have that, we can go from there and actually solve for the u. So what we're going to do is we're going to take the reciprocal, so we're actually going to bring that out, so it's going to be 1/8 times 2 over 3 u to the 3/2 right here. So what do we have here? So 1 times 2, 2, 8 times 3 is going to be 24. This simplifies to 1/12. So we're going to have 1/12 u to the 3/2. Now that we got this, we can now substitute our u, which is 4z squared minus 5. So it's going to be 1/12 parentheses 4z squared minus 5 3/2, and that's going to go ahead. Oh, don't forget your plus c. Just remember, whenever we're dealing with a dz or anything else, we're going to have plus c. I keep doing that in the tutorials. But that is going to be your answer right here in this corner. Oops, sorry about that, guys. And if you guys have any questions, please let me know. That is the answer. So now we're going to be doing section 7.2, question number 17, and this also deals with substitution. So this one's a little bit wonky, guys, because we're going to have a natural log, but just bear with me and I'll try to explain it to you guys. So we're going to use the number underneath the radical, which is going to be the t squared plus 2. We're just going to use that as our u. We might as just well. Just easier that way. So we're going to do t squared plus 2. So now we need to find du. So basically we're just going to take the derivative, which is just 2t dt. So we got a dt. Awesome. We got a t right here. So great, but we don't need that 2. So we're going to go ahead and divide each side by 2. So we're going to have 1/2 1 over t dt. Now if you're wondering, why are you putting that t on the bottom? Well, let's see. Since we already found the t up top, we can just put a 1 on the bottom, or 1 on top, and then just put a t on the bottom, because usually that's just what we're going to do. If you have any questions, I can explain it better, but that's why we're doing it for this problem. This is the correct way to do it. Now, if you look, you're going to see that you can't really take an antiderivative to this because it's going to be 0. That means we got a natural log. When you see 1 over t or 1 over x, that just means natural log. So basically all this is going to be, I know it's weird, but bear with me, we're going to have 1/2 natural log of the absolute value of t plus c. So u and t, same thing. I know I wrote u up here, but that's basically the same thing. So basically, all this, when this is all simplified and out, it's going to be 1/2 the natural log of our u value is going to be t squared plus 2, t squared plus 2 plus c. Now, since we see this right here is no matter what's going to happen to it, it's not going to be negative because it's going to be a positive number. We can just go ahead and put this in brackets. So you can either have this answer right here, which is 100% correct. Don't get me wrong, it's 100% correct. But if you want to get some extra bonus points, which really they aren't bonus points, they're just really how you're supposed to do it, you're just going to go ahead and take those absolute value brackets out and put parentheses plus c. So that's how you're going to go ahead and do problem number 17 on section 7.2. I know this is a little wonky. If you guys have questions, just email me. I'll be happy to ask. Or answer, not ask. You guys are the ones answering the questions. Alright guys, so right now we're going to be doing section 7.2, question number 25 on the practice problems. So how to do this problem right here is going to be kind of weird, so just bear with me. This is, again, another one of those wonky problems with substitution. So we're actually going to go ahead and have what's in the radical right here be our u value. So we're going to have u equals y minus 1. And but here's the thing, you can't really take the derivative of that. So again, like I said, it's kind of crazy. Just bear with me. So what you're going to do here is you're actually going to solve for u. So you're actually going to go ahead and add 1 to both those sides. So you're going to get y equals u plus 1. So that's actually going to be not your derivative, but that's really what you're going to put on the top of the problem. So now we're going to rewrite this out as just this, which is going to be u plus 1 over the square root of u. Now, if you're wondering why we're writing it out like this, it's well because we really don't have a derivative to work with, so we had to solve for u. And now that we have that, that's going to be on top, and the reason why we have square root of u is because of this square root right here. So basically, if you want to think of it, it's just the reverse of this. Basically, if you guys want to think of it like that. So now what we're going to have to do now is find the antiderivative. But here's the thing, we really don't want that radical u in there. So what we're going to do is we're going to do with one of the previous problems, we're going to bring it up top. So this basically just means u to the negative 1/2 power. So we're going to have u to the negative 1/2 times u plus 1. So whenever you're multiplying exponents, you're actually just going to be adding. So we have u to the negative 1/2 plus u to the first is actually just u to the 1/2 plus we're going to have u to the negative 1/2 times 1, just u to the negative 1/2. Okay? Now that we have that, now we can take the full antiderivative. So we haven't done that yet. So we're going to be adding 2 to the top, so it's going to be u to the 3/2 over 3/2 plus we're going to be having adding 1 to the top. So that's just going to be regular just u to the 1/2 over 1/2. Now you kind of want these up top, so you're going to multiply by the reciprocal, which is just going to be 2/3 u to the 3/2 plus 2u to the 1/2 plus c. And that is going to be your answer right here. I know it's kind of counterintuitive. Let me try to explain it once again. So, because we cannot find a derivative for this, because that basically just means y minus 1 is just y to the 0 power, just 1. You just can't have that. That can't be a derivative. So what you're going to do is just solve for u, and we're going to put that in place for the numerator. And then we're going to put the regular y, or the u, into the denominator, just like in this regular problem right here. And then we're just going to go ahead and solve it like we did. So that's going to be your answer for question number 25, section 7.2. So right now we're going to be doing section 7.3, question number 5. Now this one is another one of those doozies. This is going to be using left, right, and then midpoints. So the formula we're going to be using to this to find out how far we're going to go from each point is going to be b minus a over n, which translates to b is always going to be the highest x you're given, so that's 4, and then minus the lowest, which is 2, over n, and they give us n in the problem, it's 4. So it's 4 minus 2 over 4 equals 1/2. So what we're going to do to find the left endpoints, we're going to be going ahead and actually plugging the equation 2x plus 5 into the graphing utility. You're going to be getting your graph, okay? So there's a reason why you're going to plug it in, and I'll explain it later. So from the left, I'll show you the graph that I actually hand drew right now. Right here, I don't know if you guys can see it. So basically, we are going from the values 2 to 4. So the left endpoints are always going to be 2 up to the next closest to 4. So let me explain what I mean by that. So our left endpoints are going to be 2. Then we're going to add the half to every single one. So it's going to be 2.5, 3, 3.5, but we don't go to 4. And then for the right endpoints, it's going to be 2.5, 3, 3.5, and then 4. Now why is that? Well, you're going from the left, so from the very leftmost thing on the graph is going to be 2. Plus 1/2 is 2.5, plus another half is 3, plus another half is 3.4, but that's all we want. We want all the left-bound stuff. Then from the right, we're going from 4 to 3.5 to 3 to 2.5, all minus 1/2 on each. So that's why that's going to be the left and that's going to be the right. Now, we need to find the values of the y values of 2 when x equals 2. That's where the graphing utility comes in. So when you plug into the formula, you're going to go into y equals, and you're going to type in the 2x plus 5. So once you type that in, you're going to press graph, and then you're going to get your graph. Now you're going to go to trace, and then you're just going to type in 2. So at 2, the y value is 9. So we know it's going to be 1/2 times 9. Now, if you're wondering why you put the 1/2, it's because that's what that number is from each endpoint, is 1/2. So we're going to put 1/2 up front, plus we're going to plug in 2.5. The y value is going to be 10, plus 1/2 times times 10. Sorry. Then we have 3. So we're going to type in 3, and that's going to give us 11. So we're going to have 1/2, 11. Then 3.5 is going to be plus half of 12. So once you go ahead and put that into your calculator, you're going to get, I believe, let me get my calculator. You're going to get 21. So that's going to equal 21. Now we're going to do it for the right endpoints. So we know that when 2.5 is the x value, we have 10, so it's going to be 1/2. So these are the lefts. The left side is going to be 21. That's the left. Now we're doing the right, just to clarify for you guys. 10 plus, so now we have 3, which is going to be 11, plus half of times 11, plus, then we have 3.5. It's going to be 12, plus, when we type in 4 onto the calculator, y value is going to be 13. So it's going to be 1/2 13. And when you plug all this into the calculator, the right bound is going to equal to 23. Now to find the midpoint, or the mid-bound, what you're going to do is you're going to add 23 to 21, which is going to equal, can't do simple math in my head, 44, and divide that by 2, it's going to be 22. Now, in order to check to see if this is right, what you're going to do is you're going to take all your values. So you're going to go from the left bound and right bound values is what I mean. So you're going to go 2, 2.5, 3, 3.5, and 4. Now we want to find the midpoint between each of these. So in between 2 and 2.5 is 2.25. Now in between 2.5 and 3 is 2.75. And in between 3 and 3.5 is going to be 3.25. And in between 3.5 and 4 is going to be 3.75. So now that we have these values up here, we're actually going to go ahead and do the same thing we did before and plug 2.25 into the x value. It's going to give us 9.5 plus 2.75. That's going to give us a y value of 10.5 plus we have a y value, an x value of 3.25, which is going to be 11.5. And then now we have 3.75. Plug that into the graphing utility. It's going to give us 12.5. And if you plug all that into the calculator, you're going to get 22. So 22 is in fact the right answer. Now the reason why I showed you how to actually check it is because on the test he's going to ask you to, hey, check, make sure it's right. And that's how you're going to go ahead and do it. You're just going to find the difference between all the points you actually did. And it's between all of them. So from 2 all the way to 4. And you know it's the 0.5s because the 1/2 right here. That's how much you're going to go up. That's how much you're going to go down from the right point. So yeah, if you guys have any questions on that one, please let me know. So this is how we're going to be doing section 7.4, question number 7 on the review. So in order to do this one, we're going to be defining the integral, or finding the definite integral, whatever the frick you want to call it. So in order to do this, of course, just like a normal problem, you got to find our u value. So we're going to set u equal to 4u plus 1. We're going to go ahead and take the derivative of that, just the regular derivative, which is just going to be du equals 4dx. And we're like, whoa, shoot, dog, we got no 4 nowhere. So we're going to divide by 4, divide by 4. So basically that's going to go to, as 0 approaches 2, 1/4, 3, square root of u dx. But here's the thing now, guys. Now that this number is changed inside the radical, we need to change these numbers right here. So in order to do that, you're going to go to your original u value and just plug in whatever these numbers are and find it. So we got 4 times 2 plus 1 is going to equal to 9. And then 4 times 0 plus 1 equals 1. So now we get to rewrite this as, we're actually also going to go ahead and take the 3 out. 1/4 times 3 over 1 as 1 approaches 9, square root of u dx. We're going to go ahead and multiply this out, which is just going to be 3 over 4, 19 u to the 1/2 power dx. Now that we got this here, we can go ahead and take the antiderivative of u, which is going to be u to the 3/2 over 3/2, 3/4 as 1 approaches 9 dx. So now we can go ahead and evaluate that for our two values. So we're going to have the 3/4. We're going to have this outside. Go ahead and put that in bracket. So we're going to put 9 right here, 3/2 power over 3/2 minus 1 to the 3/2 power over the 3/2 power. And when we actually go ahead and evaluate that, this right here is going to equal, I believe, 18. Make sure my math is right real fast. Hold on, just give me 1 second. Yep, this is going to, right here is going to equal 3 over 4, 18. minus 2/3. Because once you plug, you can actually just plug this into your calculator and you'll get the right answer. So this right here in the brackets right here is actually going to equal 17.33 continuous. If you want to be, literal with it. And then you're going to multiply that by 3/4. And when you multiply that by 3/4, your answer is going to be 13. And that's going to go ahead on how you're going to do 7.4. Sorry, I had to look at my notes and make sure I was doing everything right. I didn't want to have to pre-calculate anything. Or I already pre-calculated anything, and I just want to do it that way. So you guys have any questions on section 7.4, question number 7? Please let me know, and I'll be able to help you guys as much as I can. Okay, so now we're actually on the last problem of the review, which is going to be section 7.4, question number 13. So let me go ahead and show you guys how to do this one. So, of course, we got to find our u value, so we're going to go ahead and make 2x minus 7 our u value. So, u equals 2x minus 7. Alright, so that basically just means du equals, once we take the derivative, it's just 2 dx. But what's great here is that we have a dx right here and a 2 up top. So we're already coasting right now. So now what this means is that we need to find the two new values for here once we find du and everything else. So that's going to go ahead and be an understood 1 up top, u squared dx. Now to find these two new values right here, all we're going to have to do is plug in the 4 and the 6 into this x over here. So we're going to do 2 times 6 minus 7. So 2 times 6 is going to equal 12 minus 7 equals 5. 2 times 4 is going to equal 8 minus 7 equals 1. So our new values are going to be 5 and 1. Okay, now like early on in the other problems, we do not want that squared on the bottom. We're going to go ahead and bring it up top. So that's basically going to be u to the negative 2 times 1 over 1, understood, dx, and of course all those other shenanigans here. So that just, u to the negative 2 power times 1 is just u to the negative half over 1 dx, squiggly lines. Now we're going to go ahead and take the antiderivative of this. So we're going to add 1 to it. So it's going to be u to the negative first over negative 1 dx, squiggly lines always. So now that we know this, we're going to go ahead and bring this u back to the bottom because we don't want the negative on top. So we're going to go over here now. So it's as 1 approaches 5, 1 over, it's going to be negative now because there was a negative 1 on the bottom, u to the first power, dx. Now we can go ahead and exchange our u values, which are now 1 and 5, into that u on the bottom. So it's going to be 1 over 5, negative 5, minus negative, which is going to be 1 over 1, which is just, again, just 1. So once you go ahead and do that, change the signs, it's actually going to equal to positive 4 over 5, and that is going to go ahead and be your answer. If you guys have any questions on how this was solved, or if you have any questions in general, please let me know. I'll do my best to answer. Thank you guys so much for watching. I'll see you guys next math video.